All right, so let's just go ahead and talk about what's actually on this exam that you're going to be taking tomorrow or whenever you watch this video. So I have one of these for pretty much all of them, and we call this the test blueprint, which is what I tell you where everything's on. So the test is constructed first, 1 through 4. This is a question that gives you grams in a volume and asks for molarity. All right, you might remember, hopefully you remember actually, if you're asked for molarity and you're given grams in a certain volume, it's the one where you have something in all four um, quadrants, so to say. So it'd be something like, and this is not the test, but it would say you have like 50 grams of LIF in 300 milliliters of water. Um, well, it would say solution, but it doesn't matter. So you would have to find LIF, so that's 7 plus 19, so that'd be 26 grams per 1 mole. And then you'd have the 50 grams, and we always convert this by moving it 3 over, so this is 0.3 liters. So remember, if it's asking for molarity, you're solving for moles over liters. So you start with the two numbers I gave you, which was this and this. It only makes sense to put the liters, I should say that number, on the bottom because that's where we need them in the future. We put the given mass on top, and then we need moles, so we need to get rid of grams, so we flip this one over, 26 grams for every 1 mole. Now, some kids are still struggling with the math here. Um, you need to multiply the two numbers on the bottom and then divide 50 by what the answer was. So this will be 50 over zero point 0.3 times 26. Um, let's see, I don't know, whatever that is. We'll just say it's around 8-ish. Um, and then you would put your number. Okay? Um, so that is 1 through 4. Now, the way that it works for 1 through 4 is number 1, it will ask what the unit is. Number 2, it asks what proportions are given. So you have to identify these, and these are multiple choice, so they're not as bad as you might think. Number 3 says, how would this problem be set up? And then number 4 says, what's the actual answer? Okay, so that's how one question becomes 4. You just have to work through each part. So if you even just know that molarity is moles per liter, you can get some points there. All right, then questions 4 through 8. I don't know. We don't exactly cover these in class, but don't panic. What it is a graph, and it shows you some things. I'm just trying to draw kind of what it looks like. And down here it has time, and along here it has concentration of gases in the atmosphere in parts per million. And there's no science required here. So like for instance, this line is NO. You don't have to understand chemistry to answer this. It simply says what time does NO reach its highest concentration. So that wouldn't be very hard. You would just come here, look down, and it'd be about that time. Okay, so this one really, it doesn't require this knowledge from this class so far. It kind of relates because we have parts per million, but really it's just a graph reading activity where you can mostly just use um, your common sense to figure that out. Whoops. Okay, then, hold on, let me turn this over. Questions 9, 10, and 11. So 9 through 11 are very simple. You have to find molar mass. Okay, so this is simple. I'll give you one of them. It says C6H6. This is the answer to one of those three. Well, not the answer, but the question. So you just have to find the molar mass. So you take 6 carbons. Each one has a mass of 12 plus 6 hydrogen, and each one of those has a mass of 1. So 6 times 12 is 70 plus 6 more. So the answer is 76 grams per 1 mole. All right, so 9 through 11, that's all you have to do. 12 and 13, this asks you to find moles of given grams. So very simple. Let's say how many moles in 25 grams of, I don't know, H2O. Okay, so if we're solving for moles, we'll put that over here. We take our given, 25 grams H2O. We put this unit down there, grams of H2O. When we added that up, that was 18 grams for every 1 mole of H2O. And I don't know what 25 over 18 is, and I'm not going to get my calculator out. But I'm going to guess about 1.3-ish. I could be way off there. But it's the idea that matters. So always take the given, put it up top, use the molar mass. If it's grams, remember, if it's moles, remember this number is usually small. And if it's grams, the number is usually pretty big. All right, then actually this is actually 12 through, I didn't look very careful, 12 through 16. Um, so find moles given grams, and then I'm going to add or grams given moles, which is just the reverse. You start with moles up here, 1 mole on the bottom, and then the mass on the top. Okay, then we have 17, 18. Okay, so 17 through 22 are mainly where you have your percent concentrations. Okay, remember, percent concentration really just boils down um, to the idea of what you are given divided by your total times 100. And that usually is good enough. So for instance, if it says calculate the percent concentration of 14 grams of sugar, so it gives you 14 grams dissolved in 986 grams of water. So 986 grams of water, but remember it's the total. So you have to add the other times 100. Okay, so it's your given. Oh, that's a terrible circle. It's your given over your total. So it's your water and that added together times 100. So this problem is 14 divided by 1,000, because that's what that adds to, multiplied by 100. You can just essentially cross off 2 zeros and you'll get 1.4% would be the answer to that one. All right, so don't overthink these. I'm going to give you a value. I'm going to give you either the total of the solution or just the solute, and you can go ahead and figure that out. Okay, just looking real fast at number 22. This time it says how many grams of salt are needed to make this solution. So this time it gives us the percent, and I'm going to make this up. So it says that your 20% solution and that you have 200 milliliters of water. So this of solution, sorry, this is your solution. So you don't know how much salt, so that would be your X. It's over your volume of solution, that's 200 milliliters, times 100 equals 20. So algebra says to divide by 100. All right, so now you have X over 200 equals 0.2. Did I do that right? I'm pretty sure. And then multiply both sides by 200. All right, and then I think that you get 40. I could be wrong there, but I'm pretty sure. So now we would say you would have to add 40 grams. So don't be scared. It's just algebra. Solve for X. All right, 23 through 25. Um, this one's really not bad. It gives you a Pepsi label. P-E-P-S-I. All right, label. And it tells you the sugar is like 35 grams. That's the wrong number, but whatever. And it also tells you that the total is 240 milliliters. So it asks you for the percent sugar. So remember, it's your given over your total times 100. You can work through that. Okay, 26 and 27. 26 through 27 are on parts per million. Remember that is milligrams over kilogram. So 26, I give you this, I give you that, and I ask for this. So really, this is algebra. Don't let chemistry confuse you. So if I said you had 20 parts per million and that you had 10 kilograms of whatever you're talking about, oops, 10 kilograms, and I asked for how many milligrams, you simply just multiply. So you'd end up with 200 milligrams up here. It's just algebra. Okay, 28, 29, and 30. This asks for grams and gives you molarity. So you will recall, possibly, hopefully, oops, that's the whatever tool, who cares? These are the ones that have 3. These might seem longer, but they were easier. You put your liters up here, then your molarity goes here, so you'd have moles per 1 liter. This is your given, by the way. All right, then you need to solve for grams. So down here you want moles, up here you want grams. And those grams would be the molar mass you would look up. If you recall, these were easy because you just take all 3 of the numbers in the problem and you multiply. All right. Next. Okay, I just lied. I'm sorry. I just looked. This is actually only number 30, is this. This is number 30. Let's do it down here. 28 and 29. That's the straight molarity again, where you have moles per liter. So you have your grams per your liter given, and your moles and your grams of your compound. This is just like the very first thing we talked about. If you're lost, just rewind and go back and watch that. Okay, now 31 and 32. Whoops, that's 2. Those are on dilution. So dilution, remember to multiply pair and divide by the loner. Okay, so the pair will be connected by the word of, and the loner won't be. So for instance, it says how many milliliters of a concentrated, I'm going to change the numbers, 3 molar acid need to be diluted to make 1.5 liters of 4 molar HCl. So these are the two numbers connected by of, so you just multiply, you end up with 6, and then you divide it by the number that's alone, so that's 3, so your answer would be 2. Okay. All right, the rest of the test is actually review 33 through 44. So as far as the review, you got to know your density. The density equation is on your periodic table. Okay, then it asks you basic questions. Like it says, it gives you an element like, I'm making this up, but like SR, and it says, you know, is it metal, non-metal, metalloid, does it conduct, all that stuff. That's the majority. Then it asks about salt, water. That one's not too bad. And then it asks about the kinetic properties of solids. So remember, they're like tightly packed, they're cold, there's not a lot of space, they have a high density, stuff like that. So that is your review. Use this video and use the review activity on the web page, and you should be good to go.